Assalamu alaikum, girls.
Walaikum assalam, miss.
Good morning. How are you?
Alhamdulillah, what about you?
Alhamdulillah, going on. But what about the rest of the students? They are all absent today till now. Okay.
I think you'll join soon.
Yeah, sure. Sure, we will be joining soon. Now you tell me, how's everything going on? What is your plan at this moment? Did you submit the
I
report
stopped
cards?
studying physics.
No, did you submit your report cards to Mr. Gulam?
Oh no, I will soon. I mean today. I forgot.
Yeah, you need to because it is, I actually don't remember what was the deadline. Okay, what about Rahma? Yeah, Rahma told me yesterday she already submitted, but you should also submit it very quickly because there should be some decision taken by the authorities regarding all this statement and everything. Okay, and Luri, what did you say? You are not studying physics anymore. Is that what you said? Or you
Yes.
why? You're not planning to take it in A level?
Of course not. Why do?
So what other subjects you want to take then?
Oh, I'll switch to commerce completely.
Okay, it's up to you. No one can force you. Whatever you are comfortable with, you can continue with that. No problem. Okay, so so you have already decided your mind that you'll be going to commerce stream. Did you speak to your parents about it?
Yes, they know.
Okay, fine, it's your wish, no problem. As I said, the one you're Walaikum salam. The one you're comfortable with, you can carry on. And but you remember one more thing, that is whatever you are doing, give your 100% effort. And let's see what comes up.
Yes.
Fine. Okay, I can see two students already joining me, so we can start our class today. Yes, that is like yesterday, I was doing a paper 6 question with you girls. Do you remember? That was 62, October, November, I was doing with you. And on the question number 1, there was a graph, and as it was almost at the last of our class, end of our class, we couldn't check the whole thing. So I told you to plot the graph and tell me the answer or the result that you found there. Did anybody completed that one? I want to check with you guys. Question number 1, part C. There was a graph we have to plot. Did anyone completed that graph?
This I'll just check.
Yes. Go to 62 October, November 19, question number 1. We were supposed to draw a graph there. Just have a look whether it is done. I want to know the gradient of that particular graph because we were supposed to calculate from here.
Yes, miss. You said that you'll do that and you can.
Yes. So did you try it? I want to find the answer with you. Cosmos. Yes. What about Orpa or Rama? Is there anyone who completed this question before? 62 October, November 19. Question number 1. The rest of the questions we discussed yesterday, but you couldn't check the graph because you were not done with that. Okay. Anika, did you draw the graph?
Miss, I couldn't because they didn't have a hard copy. They didn't even try in the graph paper.
Okay, fine. Shall I proceed to question number 2 then? Shall I proceed to question number 2? I think question number 2B.
Okay, miss.
Yeah, 2B also we are done with it in yesterday's class. Okay, so I want to check with you now question number C, 2C.
Yes, miss.
Yeah. Okay. 2C, they say, look carefully at the values of L and R. Okay, they are referring us to the table number 2.1. Tick one of the box to your conclusion from the result. So, if you just look at the table, what could be your conclusion regarding the relationship between L and R? Yes, could you check and tell me what was the relationship between these two quantities if you look at the table 2.1? Okay, you can see that from the beginning, L got increased. Okay, if you look at R also, it also keep on increasing, isn't it? Okay, and we can do one thing. So we can say R is directly proportional to L within the limit of experimental accuracy. Okay, so I want to do it like this. R is directly proportional to L within the limit of experimental accuracy. And you know guys, why did I pick this answer? Because there can be a small difference between this. So it is better for us to go within the limit of experimental accuracy. Okay, so they say justify your conclusion by reference to the result. Here we have to show some calculation. How will you do that? Because you know that R is directly proportional to L, means R by L equals to a constant number. So just write down that one. R is proportional to L, so R by L equals to constant. And then from the table, you show all the calculation. R by L means 1.1 divided by 20 equals 1.96 divided by 40 equals 3.05 divided by 60 equals 4.11 divided by 80 equals 4.96 divided by 100. And then I want you to check the calculation and see what number is actually coming out. What is the result of these divisions that I wrote right now? If they all are equal, so our conclusion is correct. Even though they are very close also, we'll go with that one. Okay, so I want you to check all those points. Anika, are you doing that calculation? Or is there someone
Yes, we're
already?
doing D1, right?
C1 and
Yes, I'm doing.
C1.
Yes, D1.
No, now C1, I repeat, second square or second box. We're justifying the answer in C2. Okay, is there anyone who has completed this question already? Justify your conclusion by reference to the result. Means R by L equals to constant, you have to show. And we know that two quantities which are directly proportional to each other are actually going to have a relationship, that is R by L should be a constant number. So I told you to, from the table, do this calculation, means 1.1 divided by 20, then 1.96 divided by 40 equals 3.05 divided by 60 equals 4.11 divided by 80 equals to 4.96 divided by 100. So if you divide all these terms, then check what quantity comes in your result as a result. Roughly, I think I got 0.05. Roughly, I got 0.05. So you can write down equals 0.05. Okay. Did you find 0.05 as the result of the division?
Hello, miss. Can you hear me?
Yes, I can hear you. I told you to go for R by L equals to constant. So why don't you take the values from the table? Like I said, 1.1 divided by 20, give an equal sign, then 1.96 divided by 40 from the table I'm writing equals 3.05 divided by 60 equals 4.11 divided by 80 equals 4.96 divided by 100 equals, I want you to check the division because roughly I got it 0.05 for all the divisions that I had written. So you quickly go to the calculator and tell me, did you get 0.05?
Yes, that is 0.05.
Okay, fine. So that's the conclusion. Since all the values came same, so these two quantities are directly proportional to each other within the limit of experimental accuracy.
Okay.
Done. Now, shall we go to D? They say that D1, use the values in table 2.1 to estimate the potential difference VE across 50 centimeter of the resistance wire. Okay, now if you just look at the table, they didn't provide us the value of 50 centimeter, but they have given to us 40 and 60. So we can do one thing, we can add them and divide by 2. That will give us the middle value, which will be nothing but the resistance of 50 centimeter wire. So just write down VE equals 1.71 plus 1.10 divided by 2. Okay, 1.71 plus 1.10 divided by 2. Then check altogether what comes up. Check what is the answer coming up now. VE equals 1.71 plus 1.10 divided by 2.
Divided by
2, yes. So what's the answer coming up?
I'll tell you what happened.
Check with the calculator.
Miss, is it 1.4? 1.41?
Yeah, you can write it 1.41 volt, definitely. 1.41 volt.
Yes.
Okay. Now go to part D2. Calculate the resistance of 50 centimeter of the resistance wire by using the equation R equals to BE divided by I. Okay. Now, if you just take the part A of this question, yesterday we checked it, that is the value of I we got 0.56 ampere. Okay, so we are going to apply that value. So check it, R equals to 1.41, the one we got right now, divided by 0.56. And then check what's the answer. Okay? Check and tell you what how much.
0.56.
Yes.
I'll tell you. It's it's 2.5 ohm.
Okay, 2.5 ohm. Fine, done, no problem. 2.5 ohm. Okay. If it is done, I want you to go to E. Part E of the question and check in this type of experiment, it is sensible to keep the temperature of the resistance wire as close to room temperature as possible. Suggest one simple way to minimize the rise in temperature of the resistance wire.
Switch off the circuit. Switch off the circuit in between the readings.
Yeah, we can do that. Yes, fine, correct. Switch off the circuit in between the readings. Okay. Now, let's see what do we have in the next question. Okay, move to question number 3. It is the lens question. Okay, I want
This will be tough for me to do because I'm doing it in the phone. So even if I calculate, I can zoom in and make a large calculation and zoom out to make a big calculation. I mean small one.
Yes, but then you cannot be able to measure the lengths, right?
Yes.
Okay, fine. So then we can skip this question at this moment. Okay, Alia, we are doing 62 October, November 19, question number 4 actually we are supposed to go because I don't know. Okay, is there anyone who's having the soft copy in your hand now? 62 October, November 19, question number 3 we were supposed to do. Is there anyone having that with you now? I'm waiting us respond. Is there anyone having question number 3, 62, October, November 19 in front of you? Then I will proceed with the question. Otherwise, because you have to take some measurement. If you can't do that, it's useless to discuss this question right now. Alpha, do you have with you? Or Zareen?
Nobody.
Okay. Seems like nobody is having the paper in front of them, so leave it. So I think we can go to, shall I proceed to 63 October, November?
Yes, miss.
Okay.
Oh, no, we have this planning question. Did we do this before? Yes.
I think we did it in the class. Okay, but for that also I can give you time. Just have a look what they say here. No, I think 19 variant I didn't do with you in the class. So let's check it. A student in this, say.
Did we do it?
No, dear, I don't think so. 2019 question.
No, we didn't do this. As long as I remember, we didn't do this.
Yeah, so let's have a discussion regarding it. A student investigates the time taken for ice cubes in a container to melt using different insulating material on the container. Okay, we were supposed to melt the ice. Okay, fine. So what are the apparatus they have given to us? A copper container, a variety of insulating materials that can wrap around the copper container. Okay, fine. A thermometer, a stopwatch, a supply of ice. So what they say initially, draw a diagram of the apparatus used. Okay. Explain briefly how would you carry it. Yes, dear. Any doubt? Okay. Shall I continue? Fine. Now listen. Explain briefly how would you carry out the investigation. State the key variables that you will control. Draw a table or tables. Yes. Now, after that, they said, explain how would you use your readings to reach a conclusion. Okay. Now, first, let us identify what are the two variables that we are supposed to show the relationship. That is, they say here, the insulating materials, right? And they say, what is the time taken, right? Here they say, time taken, yes, fine. So these are the two variables.
Is it time taken and temperature, right?
Time taken and temperature, we don't know here. Time taken.
Okay. So is this time taken?
No, first listen to me. Insulating material and the time taken are the two quantities we are going to show relationship. But some of the things we have to keep constant. We'll come to that later. And one more thing is that here, what are the quantities we'll be keeping constant? First of all, mass of the ice. What amount of ice you're taking? It has to be equal for all the atoms, as well as temperature of the ice. Because you know that we can have 0 degrees Celsius of ice as well as -5 degrees. So we have to make sure we are taking 0 degrees Celsius of ice for all the atoms that we are having. Got it? So these are the two.
Mass and temperature of ice.
Yes, these two should be constant, and the variable will be insulator and the time taken. Okay?
Okay.
So you are going to draw the diagram here. Just a copper container. You can show like a beaker, a container, and you're going to place a thermometer inside, and some piece of or ice cube will be showing in the container, and then you'll be showing some insulating material around it. Could you suggest me some of the insulating material so that on the table that we're going to draw, we can just write down just to show 3, 4. Could you suggest me some insulating material?
Rubber.
Rubber. Do you think rubber will be a good one? Do we have anything else to use?
Can we go for oil or something?
Oil is not an insulator. It's a conductor. Okay, it can be listen. It can be foam, cotton,
wool, yes.
Yes, cotton wool, plastic wool, foam. This can be the example. So in insulating, when you are going to draw the table, you will be writing the first column as insulator, and below that you can suggest some of the things like this. Okay, now you tell me what will be the procedure. Means what is your idea? What are you going to do here?
Well, we'll see. We'll use the different insulators, and then we'll check the temperature, and then we'll compare the results. The one with the least temperature has the.
Wait, Anika, wait. We are not discussing here about the temperature. It's about the melting.
Time.
Melting.
Okay. So we'll just measure the time taken for melting.
Yes, but
so the one which melts the least is the best insulator.
They didn't ask for that. They're just asking us to show a relationship between the insulator and the one.
We have. So what do we write for the result?
Result will be different. Materials have different times or different. Yeah, you can say that. Different
insulators have different melting.
They took different time or takes different time to melt a certain amount of ice. That's it.
Okay.
But here you can mention one more thing, that the ice that you're taking should have the temperature of 0 degrees Celsius, as well as when it melts, as soon as the water becomes 0 degree, means all the ice has to be melted and the temperature of water should be 0 degrees Celsius. Then you have to immediately stop the stopwatch, because 0 degrees Celsius of water can immediately go to 0.5 degree to 1 degree Celsius of temperature water. So we cannot continue till that point. It has to be only 0 degrees Celsius of ice.
So the ice has to melt completely, and the temperature of water should be 0 degrees Celsius.
Exactly. Then the time you are going to move down. You will switch off the stopwatch and take the time. That's it.
Yes, when do we start the stopwatch again?
When you are going to see that the temperature of ice is 0 degrees Celsius. Then immediately you switch on the stopwatch and wait there.
But we are using the ice with 0 degrees Celsius
But
temperature,
I
right, miss?
told you that all the time we're not sure that it will be 0 degrees Celsius. So after keeping it, we
Okay.
use the thermometer and check. If it gives us 0 degrees Celsius, immediately we start the stopwatch and wait there. Allow them to
Okay.
keep on
Start
melting.
stopwatch when it's 0 degrees Celsius.
Yes. And it will start melting. We'll wait until it melts completely and the temperature of water should be 0 degrees Celsius. Then
Okay,
immediately we'll
miss.
switch it off and take the time taken for this whole procedure. Done. Now, what are the precautions we have to write down? First of all, that as I said,
Ensure same amount of ice taken.
equal mass of ice taken for this attempt, as well as
And equal amount of insulation.
no,
Can we do
it's
that?
not. It's not necessary. We can do one more thing. As I said, initial temperature of ice should be 0 degree, as well as room temperature has to be constant.
Room
Because
temperature constant.
yes, keep the room temperature constant as well. Because if you increase the temperature, then the procedure of melting ice will also increase. Then it cannot be a good comparison between the different insulating materials. Right?
Yes, miss.
Okay. Now, shall I go to 63 October, November 19 girls? Those who are in my class, all of you, check 63 October, November 19. And I want
Miss,
to
I'll
start.
do the question and I'll send you, okay, miss?
Yeah, sure, why not? Question number 1 now. 63 October, November 19. All of you find the variant. We will be starting
I'll
from
just
question number
take
1.
a minute to download it, miss.
Yeah, do that. 63 October, November 19. And question number 1. Yes, all of you check that. And those who are having the soft copy with you, just find the search for the question. I want to solve it today. Done, girls. Shall I start now?
Miss, just a minute.
Yeah. 63 October, November 19. Question number 1. It is about a current electricity question.
Done, miss.
Yes. Check question number 1. It's a current electricity question, as I said. Okay. They have given us a circuit. And they say, if you check the diagram carefully, there's a crocodile clip with a lamp, and there's a wire, and there's an emitter as well. Okay. They say, on the figure, draw the symbol for a voltmeter connected to measure the potential difference across the lamp. So they said across the lamp. Fine. So draw it across the lamp.
To the lamp.
Parallel to the lamp, definitely. So you just draw a connecting wire and place the voltmeter, the symbol of the voltmeter in the lamp. Done? Okay. Now let's go to part B of the question. And those who are here in my class, if you have that variant, open it in front of you so that you can also compare with me. 63 October, November 19, question number 1 we are doing. Okay. The student connects the crocodile clip to a length of 20 centimeter of the slide wire. He measures the potential difference V and the current I for the lamp. Record the voltmeter and the ammeter reading shown on the figure. Okay. Now, tell me in voltmeter, what is the reading?
0.6 volt and 0.14 ampere.
Okay, let me check it here. 1, 2, 3, 4, 5, 6. Yeah, 0.6 volt, and here we got
0.14 ampere.
1, 2, 0.14. Yeah, that is correct. 0.14 ampere. Okay. Now check the part B2. Calculate and record the resistance R of the lamp when the length is 20 centimeter. By equation, R equals to V by I. Okay. So you got V as 0.6 and I is 0.14. Do the division and tell me what could be the answer for that. Check.
Miss, it's 4.3. 4.3 ohm.
Yes, 4.3 ohm. And the rest of the values are given in 1 dB. So we can go for 4.1. Okay, fine. So after that, we have a graph question. So I'm not sure whether you'll be able to do that. Yeah, you can skip it. And then do one thing, go to part E of the question. I think this one you can do because it is about a circuit.
Then I can do.
Yeah. you have to draw a circuit. And they said in this type of experiment, it is possible to change the current in the lamp by using a variable resistor. So they are asking us to complete the diagram to show the position of the variable resistor. Okay, fine. So I want you to tell me how you place the variable resistor in the circuit, because they have given us the power supply only. You have to, and they gave us the lamp.
Series, like with the ammeter, will extend it.
Yes, you can do that. You can place it there or on the other side also, no problem. Means it has to be only in series with the rest of the, means with the ammeter and the lamp. It has to be connected in series. Okay, and then across the lamp, you are going to place the voltmeter. The one already we had in our previous diagram. Okay, so I think it's done. Now we have to go to question number 2. But it is also Lynn's question. If you are not having the soft copy, you cannot do it now. So I think you have to skip the whole thing right now. Okay, go to question number 3 now. Here also we are supposed to measure. So I'm not sure will you be able to do that. I think only part A I can do with you. L0 you have to measure from the string. Okay. No, I think we can do this because the value of L0 is given. So I think we can do that. Okay, fine. Let's do number 3. 63 October, November 19, question number 3. Okay, now check. The class is investigating the behavior of a spring and then using the spring to determine the weight of an object. Okay. They gave us the diagram. The stretched length L of the spring indicated in figure is to be measured. Okay. Describe 2 precautions that could be taken when measuring the length of the stationary spring to ensure the accurate reading. You may draw a diagram. Okay. So what is your idea? How will you do that?
First, it is like ensure your eyesight is perpendicular to the reading.
Yes, but before that you have to place the rule, isn't it? So that point can be our first point. So you can write that place a meter rule parallel and as close as possible to the spring. It has to be close. Okay. So place a meter rule parallel and close to the spring. Parallel and close to the spring.
Spring.
Yeah. Then the other one that you say, you can just write that one in number 2. That is, ensure your line of eyesight is perpendicular to the reading of the meter. That's how we always say. So that is correct. Is it done? Now let's go to 3B. In 3B, a student measures the length L0 of the spring without any load as 2.1 centimeters. Okay, fine. Now they're saying various loads L are hung on the spring. The stretched length L of the spring are noted, or each load is noted on the table. So we have to find the extension. Okay, we can do that. Because the original length of the spring was 2.1. Okay, it's 2.1. So 2.1 centimeter, okay, and then we have to just subtract. Like we have here 6.3 and minus 2.1 will give us 4.2. And again, you have 10.5 is the extended length minus 2.1. And the extension is getting 8.4. Are you matching? And then the third one we have 14.7. Subtraction, you are going to subtract 2.1 from here. Then you'll be getting 12.6. Then you'll be getting 12.6. Okay. Now I think it is done. Let's go to the other page, that is 10, page number 10 of the question. Number C. Ready, girls? Shall I go to C now? Hmm. Anika, are you done with the previous question? Hello, Anika, are you doing? Are you following my class? Hello. Okay. Seems like we got disconnected. Okay, fine. Now, in part C of the question, 63 October, November 19, question number 3C we are doing. In part C, they are showing us a
Yes, ma'am.
diagram. Yes, a diagram is there. And they told us to measure the length. Okay, I'm not sure. Can you do this now? I don't think so, right?
Yes, miss, can I just measure it in my screen and tell you?
But will it be correct?
I don't
Because
know.
no,
I
no,
just
no. Because on the mobile screen it will be showing us a small diagram, so that will not match with your diagram,
yes,
original
it's a
diagram.
very small diagram to be honest.
Yeah, obviously. So let's do one thing.
I'll get
Uh,
approximate. I'll get approximate of 4 centimeter here.
no, no, no. It cannot be really much higher than that. Okay, do one thing. Leave that when you take a printout of that, then you can start doing it. Let's go to the next question, number 4. That is the planning question, and finish it off.
Okay.
Because without the proper printout, you cannot do that question. Okay. Now check. 63 October November 19, question number 4. It's a planning question as you check. It's a thermal physics question as well. Here what they're saying, look, a student is investigating. Yes, a student is investigating ways of slowing the rate of cooling of hot liquid in a container. The student knows that a lead will reduce the rate of cooling. He wants to find out if the thickness of the lead makes any difference to the rate of cooling. Plan an experiment which will enable him to compare the effects of lead of different thickness. Oh, they have given us different thickness, leads of different thickness. We are going to apply it and check. So now you tell me what could be the relationship over here? Means you are going to use different leads and
The more the thickness,
yes,
the more the rate of cooling.
more the rate of
The less the
cooling,
rate of cooling.
less the rate of
Less the
cooling.
rate.
But what are the quantities you are going to measure and tabulate that? What are the quantities?
Temperature.
Which temperature?
Temperature of the water.
They said we are going to check the hot liquid. So will it be initial temperature, then final temperature,
Yes, and
and
then we subtract it.
yes, that is temperature drop, but we have to ensure that we are keeping the same time interval.
Okay, yes, time interval.
Yes. Just imagine that you're going to give a time interval of 2 minutes. Then all the attempts that you're going to make with different thickness of leads, same interval, and we are going to take the temperature drop within this time. Within this time interval, the temperature difference or the
So another
temperature.
variable will be the time, the
No,
first variable.
no. Time interval is a constant here. It's a key variable that we are going to be controlled. And here it will be about the thickness of the leads that they have given to us. And then, okay, now you tell me one thing. How will you measure the thickness of the leads actually?
Using a micrometer.
Yeah, we can do that, but we need to do that. Or by the look, we can understand the thickness of that. We can just put the name or give some number according to the smaller to the higher thickness, and then
Yes,
just
we
take
can do
it.
that.
Yeah, that can be done. That can be done, and we are going to find out the temperature drop within the particular time. And the more
Yes.
the temperature drop means the less the thickness. Right? The
Yes.
more the thickness, the less the temperature drop. That will be the conclusion. Okay, but they told
Yes.
us, let me take list of the apparatus. They said, okay, I didn't notice that. We have to write down the list, and you can draw a diagram that will help you. Like you'll be drawing that is a beaker, we can say a glass beaker we'll be using. Then a thermometer is needed. The plastic lead of different thickness. They said here what they gave to us, thickness of lead. Okay, we can just mention plastic lead because of course plastic is an insulator that is used as a lead as well. So that will be the plastic lead of different thickness. Okay, and definitely we need a stopwatch. Okay,
And then some water inside the beaker.
What?
Water inside the beaker?
Yeah. We'll not mention about the water because it's a regular supply. It will be there in the laboratory. Or hot water also you can write. So our first step will be like we are going to pour some hot water on the glass beaker, and you can say arrange the apparatus according to the diagram.
Yes.
And we can do one more thing, like we are going to cover this beaker with the lid with the least thickness will start. Okay, with the least thickness will start because we are having a set of different thickness of plastic lid of different thickness, a set of that we have. So we'll start with the least. And then we can note the initial temperature. And after a certain time, immediately we have to switch on the stopwatch while we are noting the initial temperature. Switch on the stopwatch, and after a certain time, find out the final temperature and switch off the stopwatch as well. After a certain time, so we don't need to discuss about the stopwatch. We have to say just after a certain time, take the final temperature of hot water. Then we just find out the temperature drop by subtracting both the temperature. So del theta equals to theta 2 minus theta 1. Okay? Then the result will be definitely the more the thickness, the less the temperature drop. Isn't it? Okay.
Yes, miss.
It's fine. So what could be the precaution that you're going to follow in this procedure?
Ensure the same amount of hot liquid.
We'll write the same volume of hot water.
Same time interval. Or same temperature of the liquid.
Initial temperature, you have to say.
Yes.
Same initial temperature, as well as you can say same room temperature, or keep the room temperature constant. That is also a key point. You can keep it as a constant. Okay. Okay. Now, as we are done with the paper 6 questions of 2019, all the questions, right? May, June, and October, November.
Yes, miss.
Okay. So now we can go back to paper 4. Now, do you remember what was the last paper 4 I did with you? Did I reach 42 October, November 19? Or 41 I was doing? I don't remember you. Could you help me? Which one I was doing with you? Is it 41 October, November? Or 42
We were
October?
doing 41.
Did
41.
I finish this?
Yes, you finished it. And the 42 also we finished, miss.
Okay.
We finished 2.
So we need to go to 43 October, November 1950, right?
Yes.
Okay. So do you have it with you or you need time to download it?
Miss, I'll take 2 minutes to download.
Okay, do it. I'm ready. So by the time I want to talk to Amina and Fatima. Are you together? Amina and Fatima?
Yes, miss, we are together.
How in this
Congratulations.
curfew time, how did you meet each other? Fatima, could you
Miss, the thing is, she lives near me.
welcome back, girls.
Thank you, miss.
Yes, I'm waiting.
Miss, I downloaded the paper.
Very good. So that was 43 October, November 19, isn't it?
Yes, miss.
Okay. Just hold on. I'm just waiting for the others to join me. I think they're on the way. Okay. Let's see who else are there. No, they didn't join till now. Okay, let's see. Okay, fine. Anika, just take the question that we have there. Question number 1.
Yes, I have
It's a general physics question.
aquarium question.
Yes.
Tank aquarium.
Yes, just have a look. Sanjita and Alia, do you have this question? 42 October, November 19. Question number 1.
Yes, miss, I downloaded it.
Okay, very good. So let's have a look at it. Look at that question. Alia, do you have with you? 43 October, November 19. Okay, Alia and Sanjita, did you submit your results to Mr. Gulam? Okay, fine. But Sanjita, what about your result? Did you submit it to him? Sangeeta, are you there? Oh, you will submit. Okay, fine. But what about your idea? How was your result in grade 8 and 9? Actually, I don't remember. 8 and 9 final term. That's what they're going to check, right? That's what they say. So 8 and 9, Sangeeta, was it A star for you in physics?
Yeah, Miss, in grade 8, all the subjects were Esther, and in grade 9, I think only English was
A. Okay.
bad and everything was Esther.
Okay. So let's see what happens afterwards, inshallah. Who's
And
Safa?
grade 10, oh my god, no need to say.
Who's Safa? If it is the commerce Safa, but I don't, she is not having my subject, right? A Safa student's name I can see. Who's that? Any idea, girls? Okay, Amina and Fatima.
Where,
Yeah?
Miss?
Because the student is waiting. But
It's just 4 of us for now.
no, yeah. Another one is waiting here. I can see. You will not be able to see that. That is Safa.
Oh, we cannot see that.
Yeah,
It's
yeah.
waiting.
Good. Okay. Fine. Yeah, I was talking to Amina and Fatima. Okay, so Fatima, are you there?
Yes, Miss.
Yeah, first time I
Yes,
can.
Miss, I'm there.
Okay, fine. So, did you submit, Amina and Fatima, did you submit your results to Mr. Ghulam?
No, Miss. I didn't get my grade 10's
Also
report
me,
card.
Miss.
Still
Okay,
not.
no, that one, your homeroom teacher will straight send it to me because at this moment you will not be able to come to the school, or even for us also it's difficult. So she will be typing your result and send it to him. But what about grade 8 and 9? Did you submit those two to him?
Miss, we'll send it tomorrow morning.
Okay, fine, no problem. But make sure you're sending it on time because they are going to check all those, right? Then only they will come to a decision. Okay, now I want to check this question. Do you have 43 October, November 19, question number 1 in front of you?
Yes,
So,
Miss.
fine, very good. Let's continue. It's about an aquarium. The tank is filled with salt water, and the depth of the tank, water in the tank is 2.0 meter, but the shape is different. Calculate the volume of the water in the tank. Actually, it is kind of
So
a
first
math
we can
question.
divide it into a cube and a cuboid, and then
Yeah.
we calculate the volume of cube and then volume of cuboid, and then we add it.
And like this math you do these questions, isn't it, girls? It's a math question, I feel, rather than a physics
Yes.
question. Okay. So would you like to do it and tell me the final answer because I want to pass that?
Sure.
Do it.
6.
Okay. I can see Mehreen is also here. Mehreen, what about your plans, dear? After this IGCC, when the school is going to reopen, so what are you going to do? Like, will you will you continue with the Edexcel level, and or you want to go to Cambridge A level? What about your?
I'm not really sure. I'm not really sure about that.
Oh, you didn't decide until now, right? Okay. Yeah, you have time. You can just wait for the result to be published. Then only it will be there. But even though you can just think about it, talk to your parents.
Miss,
Yes, dear.
I have this one doubt.
Mhm.
When we divide, squares should have like equal, the line should be equal, right? So one's 1.6, one's 1.1. Does it mean that both are cuboids?
No, you can do one thing. Just give a line straight, means that middle line. Then you will get divided into two parts, 1.6 into 1.1, and the other one will become 1 into 3.2.
Yes, but that's the area.
We're finding out the volume. Okay, okay. Yeah, fine. I can understand one of it. Did you notice here that they said the depth of the water is 2? So you have to multiply 2 with 2, both of them. Because volume is what? Length into width into height. So
So
we are
it's
getting.
LBH for both.
Yes. That is true.
Okay.
So you're going to multiply with 2 in both the cases. 1.6 into 1.1 into 2. Again, 1 into 3.2 into 2. Then you're going to add both.
Yes, I understand.
Okay, and then check what's the answer. Now, Nihat, I can see you are here. So, what is your plan, Nihat? Afterwards, what are you planning to do?
I did not listen. Miss, what?
What are you planning to do here after getting the IGCC result and all? Then, what is your plan? Did you think anything?
I don't know.
Yes, is the answer 9.9 cube? What?
Yeah,
What?
okay. Yeah,
9.9 meter cube.
okay, fine. Do you have any other number? Like, is it possible that it can
Yes,
go
it's
to?
9.92.
Okay, then keep it like this, 2 digits. 9.92 meter cube. Done. Okay, now you take the next part of the question, part B. By the time I want to continue with Nihat. Yes, Nihat, you were saying something. I couldn't hear it.
Okay, so mass over here.
Did you decide anything, Nihat?
I think we're going to Bangladesh.
Oh, you'll be going to Bangladesh. Okay, fine. So no problem. After going there, you can continue with their level. Any system you can switch to after that. Inshallah. And all the best for you.
Miss, is the mass 10,912
Yeah, 10,912 kg.
12
Yeah.
kg.
Yes, fine. Correct. Now you start taking part C. By the time I want
Pressure
to,
due to water H rho G.
yes, but here you have to check one thing here. The pressure due to the water at the level of 0.8 meter is set. So what is the height now?
0.8 meter.
Yes, no. What
Above
is
the base. The
base
height
of-
is now 2.1 meter.
no,
Because if we
2.1.
add it,
No, dear, you will not add. You have to subtract. 2, because initially it was 2 meter of water, right? Initially. Now
oh,
this
it's
is
2 meter of water, right?
2
So it's
minus
2
0.8.
minus
Exactly. After that, P equals to H rho.
1.2.
Yes, yes, then H rho. Okay, Aliyah, what about your plan here? Have you decided anything regarding after IGCC, what you will be doing? Aliyah, are you there? A levels. Okay, fine. You will be doing A levels, means edX A level in your school? Okay. So what about the subjects? Have you decided anything regarding the subjects? Which subject you want to do? Or you want
Miss,
to
is the pressure 13,200 Pascal?
could you just convert that one into the standard form?
Yes, I can do that.
Yeah, do that. That will be better. Okay. So Aliyah, what are the subjects you'll be taking?
Miss, is it 1.32 multiplied by 10 to the power 4 Pascal?
Correct. 1.32 into 10 to the power 4 Pascal.
Yes.
Correct. Okay. So Aliyah, it's gonna be the engineering stream for you. But what will you do with the accounting? No, Aliyah, what will you do with accounting then? You don't need to have it. If you are going with this 3 subjects of the commerce stream, science stream like physics, chemistry, and mathematics, after that also, if you feel like you will not study science anymore after your A level, then you are allowed to go to accounting, MBA, BBA, any other subjects. Okay, fine. If it is your family decision, we can't say anything about it. Okay, fine, no problem. Now, listen, let's go to question number 2, 43 October, November 19, question number 2. Okay, I hope you have in your hand this question paper or on your screen.
Yes, I'm seeing the question.
Yes, fine. So I want you to read out and suggest the answers for me. Amina and Fatima, you can also follow my question, the one that I'm doing now. 43 October, November 19, and question number 2. State in words the equation that defines the moment of the force. Okay, they're asking
Turning
us,
effect of a force.
not like that here. It's an equation, word equation they're asking.
Oh, it's moment equals force into distance.
You're missing a single word there. What could be that word? A word is missing in your answer. You say moment equals to force into distance.
So,
no, dear. Perpendicular distance.
Force into distance. That's what it said. Moment equals force into distance.
No, dear. It will be moment equals to force multiplication perpendicular distance, not only distance.
Perpendicular.
Yes,
Okay.
that word is very important because we know
Let's
that
add
these
that.
two has to have an angle of 90 degrees to each other. Okay.
Yes.
The next part is that state what is meant by the force, moment of the force.
How can I say turning effect of a force?
Yes, you will say that now. Turning effect of the force is called momentum. That's it. Expect. Okay. Then let's take the next part of the question. Force is a vector. Explain what is meant by the term vector. You tell me.
Quantities which have magnitude as well as direction.
Correct. That's it. Quantities which has magnitude and direction. Now, if you just look at part B of the question, they have given us a crane, which is used to lift the load on a construction site. Explain how the counterweight prevents the crane from toppling over. Okay.
Because it neutralizes the force in the crane, like
No,
how do I
yeah,
say
it's
it?
not about the
Total upward force equals total downward force. It was something like that.
no. Before that, we have the first one that is regarding with the moment. Means we know
Oh, okay.
that clockwise moment should be equals to the anti-clockwise moment.
Anti-clockwise moment.
Yes, but you have to check counterweight is going to provide us anti-clockwise moment. That one also you have to mention. Because 2 marks came, so you'll be writing like the counterweight provides anti-clockwise moment to the crane and total clockwise moment by the load equals to total anti-clockwise moment by the counterweight.
Miss, I'm sorry, could you please repeat that?
It provides, means the counterweight I'm talking about, it provides anti-clockwise moment to the crane. It provides anti-clockwise moment to the crane. Then you can put a comma. Total clockwise moment by the load. Total clockwise moment by the load. Yeah, that is an equal sign. Total anti-clockwise moment by the counterweight. Total anti-clockwise moment by the counterweight.
Okay.
Done. Now let's move to question number 2. They have given us a waterfall, the diagram of the figure of the waterfall. They say here, take the main energy transfer, which is taking place as the water falls. Okay. I want the answer from someone from the class. Anyone else can give me the answer of this question? When the water is falling.
Is it hydroelectric energy?
Potential energy to kinetic energy to potential energy and sound energy.
Okay.
Isn't it hydroelectric?
No. Hydroelectric is not. We are not producing electricity from there. The one Sanjita said the answer that is very close to the correct answer. But we'll be just saying because when the water was above the fall, it was having gravitational potential energy. Yes. When it is falling downwards, it will be converted to kinetic energy. So this much is enough. So gravitation and potential energy. To kinetic energy. Yes, gravitation and potential energy to kinetic energy. That's it. The speed of the water as it hits the bottom is 21 meters per second. Calculate the height H of the waterfall. Okay, as we say that they are converting, and always we know that whenever there is a conversion going on or a transfer of energy is going on, we consider that none of the energy is getting wasted. So we can first write down that point, which will be giving you 1 mark. That is, kinetic energy gain equals to GPE loss, or GPE loss equals to kinetic energy gain. Right? Then GPE is what's the equation? MGH. So MGH
equals half mv square.
Yes, and as well as in case of GPE, you'll be writing MGH equals to half mv square. Okay, from there you'll be getting an equation for H. Okay, by rearranging what equation you are getting for H? MGH equals to half mv square. So 2GH equals to V square by cross multiplying. Then H equals to V square by 2G. Isn't
yes.
it? Yes. V square by 2G. Now you just substitute the value. They gave us the 21. V is 21. So 21 square divided by 2 multiplied by 10. G is always 10. Let's take first answer coming.
What is it again? 21 square divided by?
2 into 10 because G is 10 for you. 2G.
Is it 2,205 meter?
I don't think so. Could you check it again? 21 square divided by 2 into 10.
Yes, that's what I did.
And
Wait, I'll just do it again. 21 square by 2 into
20. 21 square by 20.
22.05
Okay, that can be the correct answer. 22.05 meter.
meter.
Hmm. Okay. State and explain any assumption that you made in part 2 of the question. Okay, what was that?
The speed and the height is like quite, they're quite same. Like it's 22 and that's 21. Like they're quite close, the number.
No, they're not asking that.
No, wait. Is it like this about the seconds time I talk about?
Which one? I didn't understand.
Okay.
Actually, they said what assumption that you made. I told you initially, right, that whenever there's an energy transformation is going on, we consider that none of the energy is lost. This is the assumption that I did. So no.
What's the assumption again? This?
No energy.
No energy wasted.
Yes, no energy lost to the surroundings.
Okay.
This is the assumption. Otherwise, we cannot use this.
No energy lost to the surroundings. Yes, Miss Right.
Magic. Part B of the question they say, the sun is the source of energy for most energy resources used to produce electricity. Take two energy resources that have another source for their energy, not sun. So could you suggest some other energy resources? They don't get the energy from the sun. Do you remember any other energy resources which don't get the energy originally from the sun? Even though we say the sun is the ultimate source of energy, but there are, yes?
It's hydroelectric energy, first of all,
No,
as
hydroelectric,
Wind, wave.
Say wind. No, that is also dependent on the sun.
wind and water.
No. Okay, tidal we can say, because tidal is depending on moon. Tide happens due to the attraction between sun, between earth and moon. So tidal energy you can take. You can take tidal energy, geothermal energy.
Geothermal energy.
Yes, this is the harnessing heat inside the earth. And another one is the nuclear energy. Nucleus has nothing to do with the sun. Nuclear energy. The one we say nuclear power reactor. Okay, so that can be. So you can write any of these three. That is nuclear energy, geothermal energy, and tidal energy. Okay. So now I want you to turn the page, question number 4 we have here. But question number 4, I think you can do it yourself. And we are about to finish our class. So next class, tomorrow I have a class with you again. So I can continue this question paper and finish it up.
We can start from we can start with question number 5 because 4 I can just complete it right now.
Yes, very easy. Question number 4 is very easy. They said here just to check with the shape and size, okay, force between the intermolecular force and the arrangement of the molecules. In terms of that, we have to explain the properties of these two. Okay,
so solids have strong forces of attraction between the molecules and vibrate in their position.
And they are tightly packed.
Tightly packed.
Yes. Liquids, loosely packed.
Liquids have less forces of attraction than solids.
Yes. Or you can say weak intermolecular force. They can slip slide over each other. Gas, they are far apart. And
widely separated.
Yes, and
move around randomly.
Yes, and they have negligible intermolecular force. That one you can mention, and then that is okay. I think, alhamdulillah, we are done with this paper. It's not done yet. We'll be completing tomorrow, inshallah. And tomorrow, after completing this 43, as you said, you have certain doubts in the motion graph. I can go to motion graph and have a discussion with you. What do you say, guys?
Okay,
Yeah,
miss.
No problem.
Yeah, we can do that.
Thank you.
Yeah, welcome here. Inshallah, tomorrow we'll have the class again. All of you stay fine and do pray all the time for all of us so that we can meet each other again physically and we can, inshallah. And we can also have a good art for us so that we can be comfortable there, right? Right now we are always in fear. What will happen? Like that, isn't it? Okay, guys. Allah Hafiz and see you tomorrow.
You too, miss. Thank you.
Yes.
Thank you.